Hello, and welcome back to this quiet corner of the universe. Take a moment, if you will, to imagine the dust in a beam of afternoon light. Each mote drifts and turns, catching the sun for a fleeting instant before falling back into shadow. The history of our world, and indeed of our species, is much the same. A collection of countless such moments, settling one upon the other, layer by silent layer. Most are lost to time, but some are captured, pressed into the deep memory of the earth. Tonight, let us wonder together about those layers, about the story they tell, and about the pages that might be missing. It's hard to imagine a world with a history deeper and stranger than the one we know, but perhaps the story we have read is not the only one that was written. If you find this journey suits you, a like or subscribe helps this small signal find other curious minds. There is, of course, no pressure at all. I'm always curious to know where on this planet you are listening from, and what time it is in your part of the world. It's a wonderful thought that we, separated by space and time, can share this moment together. Now, find a comfortable position and let your mind slow to the rhythm of time. Our journey begins. Our planet is a patient librarian. It keeps its records not in ink and paper, but in stone and sediment. For billions of years, dust, sand, volcanic ash, and the patient remains of life have drifted down through water and air, settling on the floors of ancient oceans and forgotten lake beds. With the immense, slow pressure of the ages, these layers are pressed into rock, forming a vast chronological library of time itself. This is the science of stratigraphy, the redating of the Earth's stone pages. When we look at a canyon wall, we are looking at an open book. Each band of color, each distinct layer of sandstone or shale is a chapter. Here, a dark band might speak of a time when the air was thick with volcanic soot. There, a lighter layer filled with the tiny shells of marine creatures tells of a shallow sunlit sea. In this library, we have found the epic tales of life's journey. We have found the faint impressions of the first multicellular organisms in Ediacaran period rock, strange frond-like beings living in a world we would barely recognize. We have traced the mighty footprints of the dinosaurs, and we have found the chemical signatures of the asteroid that marked their final, dramatic chapter. The story seems complete, a grand and unbroken chain of cause and effect, of natural selection and geological chance, leading from the first microbe to us. We see ourselves as the latest sentence on the latest page, the culmination of an epic told over 4.5 billion years. But any good librarian knows that books can be damaged, pages can be torn out, and entire volumes can go missing. In the great library of the Earth, there is one mystery that geologists speak of with a unique sense of wonder and humility. It is called the Great Unconformity. Across the world, from the Grand Canyon in North America to the coastlines of Scandinavia, there is a profound gap in the geological record. In many places, rocks that are around 540 million years old sit directly on top of rocks that are more than 1.2 billion years old. Sometimes the gap is even larger. Imagine picking up a history book and finding that it jumps from the early Roman Republic straight to the dawn of the Renaissance. The pages in between, the rise and fall of empires, the dark ages, centuries of human story, are simply gone. Over 700 million years of Earth's history in many places have been wiped clean. The conventional explanation is a simple and elegant one: erosion. For hundreds of millions of years, these ancient continents may have been uplifted, and the slow, steady work of wind and water wore the accumulated stone away, scouring the pages clean before the land sank again to begin recording a new chapter. This is the most likely truth. It is the story told by the known laws of physics and time. But in the quiet hours, when we are considering the sheer scale of that missing time, a different thought can emerge. 700 million years. An immensity of time so vast that our own species' entire existence would be but a footnote within it. We search this record for signs of life and civilization that we can understand, for fossils, for structures, for manufactured tools. Our search is predicated on the assumption that any advanced life would leave traces similar to our own. But what if a civilization existed in that immense missing chapter? A civilization so ancient and so different that its traces are not bones or buildings, but something else entirely. What if it did not build with stone, but with life itself? What if its technology was not mechanical, but geological? Perhaps the story isn't missing because it was eroded away. Perhaps it is missing because we have not yet learned how to read it. It may be a whisper, not in a language of fossils and ruins, but in a language of chemistry, of isotopes, of faint and lingering echoes in the very fabric of the planet. And so our journey begins not with a shout, but with a whisper, a search for a silence that might just be the quietest, most profound sound in the history of the world. To think in terms of deep time is to let go of the human scale of minutes, seasons, and lifetimes. It requires a different kind of imagination, one that can perceive the slow breathing of mountains and the patient drift of continents. 1,000,000 years to the Earth is not a long time. It is the span in which a mountain range can be born and worn down to its roots, or an ocean can open up between two landmasses. The traces of our own civilization, our proud cities of glass and steel, our sprawling networks of roads, they are ephemeral. In a few million years, the relentless forces of erosion, subduction, and glaciation would grind them all to dust. The Earth is not a perfect archive. It is a dynamic system that constantly erases and rewrites its own surface. A future geologist, searching for us 10 million years from now, would find no New York, no Great Wall of China, no pyramids. They would all be gone, folded back into the planet's crust. Knowing this, 2 modern scientists, an astrophysicist and a climatologist, posed a wonderfully humble and profound question. They called it the Silurian hypothesis, a playful nod to a fictional race of intelligent reptiles from a television show. But the question itself was deeply serious. If an industrial civilization had existed in the deep past, say 60 million years ago during the age of mammals, or even 300 million years ago in the dense coal forests of the Carboniferous period, how would we know? If all its cities and artifacts are gone, what evidence could possibly survive? What kind of fingerprint would it leave behind in the geological record? They concluded that we must stop looking for a needle in a haystack, a fossilized tool, or a ruined foundation, and start looking for a change in the nature of the haystack itself. The most enduring legacy of a global industrial civilization would not be a physical object, but a chemical shadow, a sudden and strange disturbance in the planet's metabolism. To understand what this shadow might look like, we need only look at the one example we have: our own. We are right now in the process of leaving our own geological fingerprint. The immense quantity of carbon we have released by burning fossil fuels is changing the chemistry of the atmosphere and oceans, leaving a distinct signature in the carbon isotopes of newly forming sediments. Future scientists will be able to see this spike in the rock layers, a sharp, dark line denoting a time of immense carbon release. Our creation of synthetic plastics has littered the globe with materials that will eventually break down into resilient molecular fossils, chemical markers, unlike anything the planet has produced on its own. The nitrogen-based fertilizers we use to feed our billions will run into the oceans, creating oxygen-deprived dead zones and leaving a unique nitrogen isotope signature in the marine sediment. Our agriculture has caused widespread soil erosion, washing unusual layers of silt into the sea. We are, in effect, writing a message in the language of global chemistry. So the Silurian hypothesis suggests that if we are to find a lost civilization, this is the kind of message we should be looking for. Have there been other such moments in Earth's deep past? Other sudden, inexplicable fevers in the planet's systems? There have certainly been times of great upheaval. About 56 million years ago, at the boundary between the Paleocene and Eocene epochs, the Earth experienced a period of rapid and intense global warming. Temperatures soared, ocean chemistry shifted dramatically, and there was a major extinction of deep-sea organisms. It is known as the Paleocene-Eocene thermal maximum, or PETM. Scientists have found a massive spike in carbon isotopes in the rock record from this time, indicating a huge release of carbon into the atmosphere. The most widely accepted cause is natural, perhaps the massive volcanic eruptions that were splitting the North Atlantic, cooking vast deposits of organic matter and releasing methane and CO2. This is the most logical, evidence-based conclusion, but the event serves as a perfect illustration of the kind of signal we are searching for. It is a planetary scale disturbance written in the language of chemistry. While the PETM was almost certainly natural, it forces us to wonder, can we be entirely sure? Could a natural event and the footprint of a short-lived, fossil fuel-burning civilization look hauntingly similar after 56 million years of geological blurring? The true mystery, then, is one of interpretation. We are learning to read the Earth's great library, but we may still be unfamiliar with all the languages in which it is written. We search for stories of slow, natural change, but we must also remain open to the possibility of sudden, artificial plot twists. The question is not a comfortable one, as it unsettles our very sense of place in the universe. It suggests that perhaps industrial intelligence is not a final destination, but a fleeting phase that a planet might pass through and forget, leaving behind only the faintest chemical ghost. The trail has gone cold, and the footprints have faded. We must now look for signatures in the very stone itself. So our search has shifted. We are no longer archaeologists of artifacts, but archaeologists of chemistry, sifting through the dust of vanished eons for a single anomalous grain. We are looking for a signature written in the universal language of atoms. To find it, we must first understand the alphabet. The universe provides every element with a subtle variation in its nature, a different atomic weight. These are called isotopes. Think of them as different tones of the same color, or slightly different weights of the same type of stone. Nature, in its grand, slow cycles, mixes these isotopes together in predictable, consistent ratios. The amount of the heavier version of carbon, compared to the lighter version, for example, is remarkably stable across the globe. Life, however, is a selective artist. Living processes often have a preference for one isotope over another. Plants, for instance, in the act of photosynthesis, find it slightly easier to absorb the lighter isotope of carbon, carbon-12. Over time, this preference builds up. When these plants die and are compressed into coal, oil, or natural gas, they carry this isotopic imbalance with them. They become reservoirs of sequestered sunlight, rich in the signature of life's preference. If a civilization were to then burn these fossil fuels on a planetary scale, as we are doing now, it would release this vast quantity of light carbon back into the atmosphere. This act would measurably dilute the planet's natural isotopic ratio, leaving a clear and enduring spike in the geological record, a testament to a time when ancient life was burned to fuel a new intelligence. This carbon signature is perhaps the most obvious clue we might look for. But what if their industry was not powered by combustion? What if their technology was based on a different principle entirely? The chemical library of the Earth has many other volumes to read. We might look for unusual concentrations of metals. Industrial processes, by their very nature, require the mining, refining, and concentration of specific elements. While the physical factories would have long since turned to dust, the waste they produced might not. Imagine a river delta 200 million years ago. For millennia, it patiently collects sediment from the mountains. But for a few thousand years, something changes. The layers of mud laid down in that brief window are inexplicably rich in heavy elements like platinum, cadmium, or iridium. metals that are typically rare in the Earth's crust, but are often used as industrial catalysts or in complex electronics. There would be no accompanying fossil, no tool, just a thin, dark line in a cliffside, rich in the metallic ghosts of a forgotten technology. The search can go deeper still, into the realm of the truly strange. Let us consider the elements that are born not in the belly of the Earth, but in the heart of a dying star or the chamber of a nuclear reactor. Some radioactive isotopes have half-lives so long they can serve as clocks ticking for hundreds of millions of years. One such element is plutonium-244. Its half-life is around 80 million years. This means that any plutonium-244 present when the Earth was formed has long since decayed into other elements. It is, for all intents and purposes, extinct on our world. It can be replenished by cosmic events like supernovae, which dust our solar system with it in minute, diffuse quantities. But it is also a byproduct of certain kinds of nuclear fission. To find a concentrated layer of plutonium-244 in an ancient rock stratum would be a profound and baffling discovery. It would be an element that should not be there in a concentration that cosmic dust could not explain. It would be the geological equivalent of finding a printed book in a sealed Egyptian tomb. The debate that would follow such a discovery would be immense. Scientists would rightly search for any possible unknown natural process that could have created it, a specific type of supernova that occurred unusually close to our planet, or a bizarre, unthought-of geological process in the Earth's core that can synthesize heavy elements. And they may be right. The history of science is filled with anomalies that, at first seemed artificial, but later revealed a new and beautiful natural law. The distinctive iridium layer that marks the end of the dinosaurs was one such puzzle until the theory of a massive asteroid impact provided a chillingly natural explanation. The challenge, therefore, is finding a signal that is not just strange, but intelligently so. A collection of anomalies, a cocktail of rare metals and unstable isotopes, all laid down in the same thin layer that defies a single natural explanation. We are listening for a chord in the geological noise, a pattern that speaks of deliberate action. The Earth's crust is a place of immense and slow violence, of pressures and temperatures that can forge and unforge matter in ways we are still struggling to comprehend. Any whisper of an ancient intelligence must be clear enough to be heard above this constant planetary roar. The stone keeps its secrets well, but it does not lie. The question is whether we are yet wise enough to understand everything it is telling us. The geological record, for all its majesty, is a damaged text. It is a book written on pages of stone, subject to the fire of the mantle and the relentless editing of erosion. But what if there was another library, one far older, more robust, and copied with near-perfect fidelity for billions of years? Such a library exists. It is the genome, the code of life itself, and it is carried within almost every cell of every living thing on the planet, including our own. The story of life is not just written in stone, it is written in the spiraling helix of DNA. This river of information has been flowing for nearly 4 billion years. While continents drift and mountains rise and fall, the core of this genetic text has been passed down generation after generation, from the first microbe to the vast and complex biosphere of today. It is a historical document of unimaginable age and intricacy. If the genetic sequence in a single human cell were to be printed in books, they would fill a library shelf over 100 feet long. Within this immense text are the genes that build our bodies, the instructions for creating eyes, hearts, and minds. But these genes, the parts of the code we understand best, make up only a tiny fraction of the whole. For decades, the vast regions in between the genes were a deep mystery. Scientists, unable to discern their function, gave them a dismissive name: junk DNA. It was thought to be a kind of evolutionary debris, the accumulated wreckage of forgotten experiments, disabled viruses, and meaningless repetition. We pictured our genome as a pristine, elegant blueprint, cluttered with the meaningless graffiti of deep time. But our understanding is slowly changing. We are beginning to discover that this dark matter of the genome is not junk at all. It is filled with complex switches and levers that regulate when and how the genes are expressed. It is a crucial part of the machinery of life, and yet vast portions of it remain enigmatic. Within these silent, non-coding regions, there is still an untamed wilderness. And it is into this wilderness that our quiet question now takes us. If a precursor intelligence, a civilization that thought on geological timescales, wanted to leave a truly permanent mark, one that would survive the recycling of planets and the erosion of stars, where would it place it? Perhaps it would not build a monument of stone, but a monument of information. Perhaps it would weave a signature into the very fabric of life itself. We are not speaking of a message written in human language, but of something far more subtle and fundamental, a mathematical pattern, or a sequence so statistically improbable that it stands out from the background noise of random mutation. It would be like listening to the gentle static of the cosmos and suddenly hearing a sequence of prime numbers. It would be a pattern that suggests order, not chaos, a kind of watermark embedded within the text and copied faithfully for billions of years, a quiet "we were here," written in the alphabet of adenine, guanine, cytosine, and thymine. This is a deep and unsettling thought. The theory of evolution by natural selection is one of the most powerful and well-supported ideas in all of science. It beautifully explains the diversity and complexity of life through the simple, elegant process of random mutation and environmental pressure. We are not questioning its truth. We are simply asking, with the utmost humility, if it has always been the only force at work. Consider the great leaps of evolution, moments of stunning innovation that are still debated by scientists. One of the greatest is the origin of the eukaryotic cell, the complex cell type that all animals, plants, and fungi are made of. The leap from a simple bacterium to a cell with a nucleus, mitochondria, and all its intricate internal machinery was a monumental step, an event that may have only happened once in 4 billion years. The leading theory is that it was a chance encounter, a merger between two simple organisms that, against all odds, proved beneficial. It was an accident of cosmic luck that paved the way for all the complexity that followed. But in the context of our thought experiment, we can allow ourselves to wonder, could the potential for such a merger have been encouraged? Could a piece of ancient code, a kind of biological catalyst, have lain dormant in the genome for eons, waiting for the right conditions to increase the probability of such a creative leap? Not a command, but a suggestion, a seed of potential, planted in the fertile soil of a young biosphere. If so, then we are not just the descendants of a lucky accident. We are the inheritors of an echo, a message that has been patiently waiting for billions of years for a mind complex enough to read it. The library is within us, and its oldest, quietest sections have yet to be explored. We have searched in the deep rock and in the coiled helix of the cell. Both are libraries of immense antiquity, but they are living libraries, constantly edited, revised, and sometimes erased. The Earth is a restless author of its own story, and the genome is a text that adapts and changes with every generation. If a mind wished to leave a message that could withstand the constant churn of a living world, it would have to find a place beyond that world's reach. It would need a page that is never turned, a stone that is never weathered. It would have to lift its gaze, as we do now, to the silent, loyal companion of our planet, the moon. For all of human history, the moon has been a source of wonder, a clock for the tides, a lantern in the darkness. But to a geologist or an archivist of deep time, it is something more. It is a near-perfect memory. The Earth is a world of water and wind, of grinding tectonic plates and constant biological activity. It erases its own history with beautiful efficiency. The moon has none of these things. It is a world suspended in near-perfect stillness. It has no atmosphere to carry wind or rain, and its volcanic heart grew cold billions of years ago. It is a realm of silence, where the only force of change is the slow, steady rain of cosmic dust and the occasional violent punctuation of an asteroid impact. The footprints left by the Apollo astronauts, little more than gentle compressions in the lunar dust, will remain there, almost perfectly preserved, for millions of years. They will outlast any monument we have ever built on Earth. The moon is the ultimate time capsule. It is a library of dust, where no page is ever truly erased, only covered by the next. This profound stability presents a tantalizing possibility. If our hypothetical precursor civilization sought to leave an unmistakable sign of their existence, an artifact that could not be dismissed as a natural anomaly, the moon would be the most logical place to build it. It is a billboard in our own cosmic backyard, a message in a bottle floating just offshore. Any species that evolves on Earth and develops the intelligence and technology for space travel will inevitably turn its eyes, and then its rockets, toward the moon. It is the first and most obvious destination. What better place to leave a welcome message or a warning? What form might such a marker take? A towering monolith, like the one imagined in science fiction, would be a poor choice. Over hundreds of millions of years, even the slow, patient sandblasting of micrometeorites would wear it down to nothing. The most intelligent design would be far more subtle. It might be an object made of a material that has no business being on the moon, a sphere of perfectly pure isotopes, or an alloy of metals that could only be forged in the heart of an advanced technology. It would likely be buried a few feet beneath the surface, shielded from the constant rain of tiny impacts, waiting to be found by a magnetic survey or a seismic probe. Or perhaps the marker is not an object at all, but a pattern, an arrangement of surface features, or a collection of small, identical craters in a formation that defies the mathematics of random chance, a perfect triangle perhaps, or a representation of a complex molecule. We are pattern-seeking creatures, and we have often been fooled, seeing faces in the mountains of Mars and canals in its dust storms. But a truly artificial signal would be one whose artificiality was its very message, a piece of engineered order in a landscape of natural chaos. We have only just begun to read the lunar book. We have sent probes to orbit and map its surface in ever greater detail, and we have landed machines to scratch at its soil. We have brought back a few hundred pounds of rock from a handful of locations. But the surface of the moon is vast, larger than the continent of Africa, and we have explored almost none of it. We are like travelers who have landed on the shore of a new world and examined a few grains of sand, declaring the entire continent to be empty. The search has barely begun. So the next time you look up into the night sky or glimpse the moon's pale ghost in the blue of a late afternoon, allow yourself to wonder. We see it as a beautiful, desolate world of magnificent silence. But perhaps that silence is not empty. Perhaps it is the silence of a library, waiting patiently for a reader to arrive. The earth may hide its deepest secrets, and life may rewrite its own code. But the moon simply remembers. It holds its story in the dust, waiting. Our search so far has taken us outwards to the silent dust of the moon, and inwards to the living code of the cell. But now we turn our attention back to the grand narrative of our own planet, to a time long before complex life, a time when the Earth itself was an alien world. We will revisit a chapter we thought we knew, and wonder if we have understood its meaning. Let us travel back 2.5 billion years to a world without a single animal, fish, or leaf, a world drowning in its own infancy. The Earth of that time would be unrecognizable to us. The sky was not blue, but likely a hazy orange-pink, thick with a methane smog. The oceans were not the clear blue we know, but a murky greenish soup, rich in dissolved iron. And the air was a poison to us. It held almost no free oxygen. Life existed, yes, but it was a shy and hidden thing, a world of single-celled anaerobic microbes for whom oxygen was a deadly toxin. They lived their quiet lives in the dark, still waters, drawing energy from chemical reactions, not from the sun. This was the Earth for nearly half its existence, a silent, sleeping, oxygen-poor world. And then, something changed. In the sunlit shallow waters, a new kind of microbe evolved. We call them cyanobacteria. They were the Earth's first true magicians. They had perfected a new and miraculous kind of alchemy called photosynthesis. They learned how to harness the energy of raw sunlight, using it to split water molecules and create nourishment. And in this act of creation, they produced a waste product. That waste product was oxygen. At first, this oxygen was a mere whisper in a vast anoxic world. It immediately reacted with the iron in the oceans, which began to rust. For hundreds of millions of years, every puff of oxygen produced by these tiny organisms was consumed in the great rusting of the planet. On the floors of those ancient seas, vast layers of iron oxide, rust, settled out, forming the banded iron formations that are now the primary source of our own iron ore. The Earth was, quite literally, taking a slow, iron-filled breath. Eventually, the oceans could hold no more rust. The oxygen began to bubble out, escaping into the atmosphere for the first time. What followed was not a gentle greening, but a planetary catastrophe. For the old world of anaerobic life, this new oxygen-rich air was a corrosive poison. It triggered the planet's first, and perhaps greatest, mass extinction. The world was scoured clean of much of its original life. The methane haze in the sky was cleared, plunging the planet into a series of profound ice ages. This was the Great Oxygenation Event. It was a violent, chaotic revolution that remade the world. And in doing so, it paved the way for a new kind of life, our kind of life, which depends on the high-energy fuel of oxygen to build complex bodies and brains. This is the story as science tells it, and it is a magnificent one. A story of a blind, accidental revolution, where the waste product of one form of life became the elixir for another. But let us for a moment look at it from a different perspective. Photosynthesis is not a simple process. It is a masterpiece of molecular nanotechnology, a complex and elegant engine refined to near perfection. Is it not a wonder that such a world-altering technology arose so early, and that its consequences, while catastrophic at first, were so perfectly suited to the later evolution of intelligence? Here our thought experiment takes a bold new turn. What if this was not an accident? What if it was the first great act of planetary engineering? Let us imagine our precursor civilization not as builders of cities, but as gardeners of biospheres. Perhaps they saw the young Earth, rich with potential but locked in a low-energy, anaerobic state. And perhaps they understood that to unlock its true potential, the very air itself had to be changed. They wouldn't need to create cyanobacteria from scratch. They would only need to find the most promising organism already present and provide it with the perfect conditions to thrive, to outcompete all others, and to begin its slow, patient work of terraforming the planet. The Great Oxygenation Event in this light becomes a deliberate act of cultivation. The mass extinction was a necessary clearing of the ground to plant a new kind of garden. The chemical signature left behind in the banded iron formations is not the trace of an industrial process, but of a biological one, guided with purpose. From this perspective, the blue sky we see above us and the very air we breathe are not the results of a happy chance. They are the foundational stones of a project of unimaginable scale and patience, a project whose ultimate purpose was still billions of years in the future. We are no longer just searching for a whisper. We are beginning to wonder if we are living inside the very message itself. After the fire and fury of the Great Oxygenation Event, after the world was broken and remade with a new sky and a new ocean, one might expect the story of life to accelerate, to burst forth in a celebration of its newfound energy source. With the stage now set, with oxygen-breathing eukaryotic cells already in existence, it would seem the curtain was ready to rise on the grand drama of complex life. And yet, for it did not. Instead, after the revolution, a profound and immense quiet descended upon the earth. For the next billion years, the story of life appears to slow to a near standstill. This period is known to paleontologists, with a certain dry fondness, as the Boring Billion. It is perhaps the most enigmatic chapter in our planet's history. The fossil record from this time is sparse, showing little more than the same simple single-celled organisms that had existed before. The great evolutionary innovations, animals with bodies, with movement, with minds, seemed to be waiting in the wings for an impossibly long time. The world, having taken its first great breath of oxygen, seemed to hold it for 1,000 million years. The scientific community has many elegant hypotheses for this great stasis. Perhaps key nutrients, like phosphorus, were scarce, locked away in the Earth's crust, and not yet being weathered from new mountain ranges into the sea to fuel biological growth. Perhaps the level of oxygen, while higher than before, remained in a delicate balance, just enough for simple life, but too little to power the energetic lifestyles of larger, more complex creatures. The planet, it is thought, was simply not yet ready. It was a stable but impoverished world, a quiet biological backwater. This is a perfectly reasonable and scientifically grounded view, but through the lens of our thought experiment, this long quiet takes on a different meaning. Let us return to our metaphor of the planetary gardener. No wise gardener plants a complex and delicate ecosystem on freshly scorched earth. After a great fire, the soil must be allowed to rest, to find its balance, to mature. The chaotic chemistry of the newly oxygenated world needed time to settle into a new, stable equilibrium. The planetary engine, having been violently redesigned, needed a long period of gentle running in to ensure its long-term stability. From this perspective, the Boring Billion was not a period of stagnation. It was a period of profound and deliberate patience. It was an act of planetary stewardship of the highest order. The gardeners were not idle. They were tending to the foundations. They were ensuring the new geochemical cycles were robust, that the delicate dance between atmosphere, ocean, and life was a sustainable one. Their great work was not one of action, but of maintaining a perfect, nurturing calm. They were creating not just a habitat, but a home that was being prepared to last for the billions of years it might take for a truly complex intelligence to evolve. Imagine a potter sitting with a fresh lump of clay. They do not immediately begin to shape it into its final, intricate form. They work the clay slowly and patiently, removing air bubbles, ensuring its consistency, feeling its nature. The Boring Billion was this process on a planetary scale. It was the Earth being slowly and carefully prepared. The long, quiet stability was not a bug, but a feature. It was the necessary fallow period, the long, quiet afternoon of the world, a time of deep rest before the next great awakening. This changes our perception of time itself. To our fast-paced minds, a billion years of sameness feels like a failure, a cosmic waiting room. But to an intelligence that thinks in geological timescales, a billion years is the proper amount of time to lay a foundation. It is the ultimate expression of foresight. They were not building for the next millennium. They were building for the next eon. As this long era of quiet contemplation drew to a close, the planet was finally ready. The soil was fertile. The air was stable. The oceans were primed. The long, sustained note of the symphony was fading, and a new, explosive movement was about to begin. The garden was no longer just being prepared. It was ready to bloom. The long, quiet afternoon of the earth could not last forever. For a billion years, the world had held its breath, a planet in waiting, a garden prepared but unplanted. And then, in a geological instant, everything changed. The profound silence was broken by the single most creative and explosive event in the history of life. We call it the Cambrian explosion. It was not an explosion of fire and rock, but of biology and imagination. Around 541 million years ago, the fossil record, once sparse and simple, suddenly erupts with a bewildering diversity of complex animal forms. It is a biological Big Bang. In the space of just 10 or 20 million years, a mere blink of an eye in geological terms, nearly every major animal body plan that exists today came into being. Before this moment, life was microscopic and unassuming. After this moment, the oceans were teeming with creatures that had bodies, shells, legs, antennae, and, for the first time, eyes to see the world. To look at the fossils from this period, preserved with exquisite detail in places like the Burgess Shale of Canada, is to look upon nature's most audacious and surrealist experiment. Here, we find the world's first major predator, the five-eyed opabinia with its strange frontal claw. We find the formidable Anomalocaris, a creature like an armored shrimp the size of a dinner plate, patrolling the seas. We meet the bizarre, spiny Hallucigenia, a creature so strange that for decades, paleontologists could not even decide which way was up. This was the dawn of the animal kingdom, a feverish creative moment when evolution seemed to be trying out every conceivable design. It was the invention of the chase, the hunt, the shell, the burrow. It was the moment life became animated. The scientific question, of course, is why? Why then, and why so fast? A number of conditions seem to have converged to create the perfect spark. Oxygen levels in the atmosphere and oceans may have finally crossed a critical threshold, providing the high-octane fuel needed for active, mobile bodies. The very evolution of the first predator may have set off a frantic evolutionary arms race, forcing prey to develop shells and spines, which in turn drove predators to develop better eyes and claws. And deep within the genome, it seems a critical set of genetic tools, the so-called Hox genes, that act as master switches for building bodies, had finally fallen into place. These were the sparks that lit the Cambrian fuse. This is the beautiful, accepted story of this creative dawn. But let us once again view it through the eyes of our patient, planetary gardener. For 1 billion years, they tended the soil, stabilizing the world, waiting for the conditions to be perfect. Now, with the oxygen levels just right and the environment perfectly balanced, the time had come to plant the seeds. Perhaps the genetic toolkit of the Hox genes was not an accident. Perhaps it was the very seed they had been cultivating, or even one they had planted in the living code eons earlier, as we speculated in our journey through the genome. From this vantage point, the Cambrian explosion was not a random firework display. It was an intentional, coordinated blooming. The gardeners did not need to design every creature individually. They simply had to provide the foundational tools, the genetic potential for building complex bodies, and then release that potential into the perfectly prepared environment. It was the ultimate act of trust in the creative power of evolution. They switched on the light, opened the doors, and allowed life's own ingenuity to fill the empty stage. They created the possibility for eyes, and life created 1,000 different ways to see. They created the potential for legs, and life invented 1,000,000 ways to move. The world was transformed from a quiet pond of microbes into a bustling, interactive ecosystem. The long stasis was over, and the age of animals had begun. Every animal on Earth today, from the smallest insect to the largest whale, from the birds in the sky to you and I, can trace its ancestry, its fundamental body plan, back to a pioneer that first emerged in this sudden riot of creation. We are all the children of this explosion. It is the moment our own deep story truly begins, and as we look back on it, we are left with a profound sense of wonder at the forces that unleashed it. Whether they were the blind, brilliant forces of chance, or the patient, deliberate hand of a gardener, finally seeing their garden come to life, the great creative energy of the Cambrian explosion did not fade. For the next 200 million years, life flourished, diversified, and conquered. It crept from the oceans onto the barren land, giving rise to the first vast, silent forests of giant ferns and mosses during the Carboniferous period. Strange amphibians took their first tentative steps on shore, and insects grew to monstrous sizes in the oxygen-rich air. In the Permian period that followed, complex ecosystems of reptiles and our own distant mammal-like ancestors spread across the great supercontinent of Pangaea. The garden was thriving, a symphony of countless living instruments playing a complex and beautiful harmony. And then, the music stopped. 252 million years ago, the Earth suffered a catastrophe so profound, so utterly devastating, that it came closer than ever before or since to extinguishing life entirely. It is known as the Permian-Triassic extinction, but that clinical name belies its horror. It is better known as the Great Dying. It was not a sudden blow, like the asteroid that would later kill the dinosaurs. It was a slow, creeping sickness that consumed the entire world. In the oceans, an estimated 96% of all species vanished. On land, more than 2/3 of all life disappeared. The resilient trilobites, who had survived for over 250 million years, were gone forever. The world fell into a ghastly silence. For a long time, the cause of this near-total apocalypse was a mystery. But now geologists have found the wound, the smoking gun. In modern-day Siberia, there is a vast region of volcanic rock, thousands of feet thick, and covering an area larger than Western Europe. It is called the Siberian Traps. This was not a single volcano, but a hemorrhage of magma from deep within the Earth's mantle that lasted for hundreds of thousands of years. It was as if the planet itself had broken a fever. The eruption choked the atmosphere with carbon dioxide and other greenhouse gases, triggering a runaway episode of global warming. The oceans absorbing this CO2 grew acidic, dissolving the shells of marine creatures. As the planet's waters warmed, they lost their ability to hold oxygen, turning into vast, suffocating dead zones. It was a planetary systems collapse, a cascade of failures where every part of the global engine seemed to break at once. The world was being poisoned from the inside out. In the context of our thought experiment, this event takes on a new and tragic dimension. If we imagine our patient gardeners, our planetary stewards, what was this moment for them? For nearly 3 billion years, since they first began to oxygenate the atmosphere, they had tended the garden. They had navigated it through ice ages and cosmic radiation, maintaining a delicate, life-giving balance. They were masters of a gentle, biological technology, working with the planet's subtle rhythms. The Great Dying was the ultimate test of their stewardship, and it would seem that they failed. Perhaps the Siberian Traps eruption was a natural geological event, so vast, so violent, that it simply overwhelmed their systems. Their gentle methods of geochemical balancing, designed to handle the slow cycles of carbon and oxygen, were no match for the raw, brute force of the planet's inner fire. It was the tragic moment when the gardener realizes there is a volcano rising in the middle of their carefully tended orchard. Their tools were for cultivation, not for containing the inferno of a planet's core. We can imagine them, in their slow geological consciousness, fighting to stabilize the world as it sickened. We can picture them trying to boost the biosphere's resilience, to counteract the rising heat and acidity. But the poison was too much, the sickness too deep. The Great Dying represents the catastrophic failure of their grand project. It was the near-total destruction of a work of art that had been billions of years in the making. It raises a humbling question about their own nature. Were they gods? Or were they simply life forms of immense knowledge and patience, still subject to the untamable power of the planet they called home? Or perhaps it was something more. Perhaps this catastrophe was not just the end of their project, but the end of them. Could they have been casualties of their own failing systems? Their own ancient biology unable to withstand the very poison they were fighting? Whatever the case, as the long dying finally subsided, the few hardy survivors crept out into a changed world. The Earth was a haunted and empty house. The symphony was over. But life, in its tenacious, desperate way, clung on. And on this clean, silent slate, A new chapter was about to begin, one that would be dominated by a new kind of creature. The question is, was there anyone left to watch it grow? Out of the profound silence of the great dying, life began its slow and arduous return. The world was a canvas, wiped almost entirely clean, and the few surviving species found themselves in a vast and empty home. Among the survivors were two groups of land animals who would compete for this new inheritance. On one side were our own distant relatives, the mammal-like synapsids. Before the extinction, they had been the dominant land animals, a diverse group on the verge of greatness. Now they were a tattered and diminished lineage, clinging to survival. On the other side were the archosaurs, a group of reptiles whose descendants would include crocodiles, pterosaurs, and the dinosaurs. In the early days of the Triassic period that followed the extinction, it was not clear which group would prevail. The world was hot, dry, and difficult. But as the millions of years unfolded, a clear pattern began to emerge. The archosaurs thrived. They evolved a new, more efficient upright posture, with legs directly beneath their bodies, allowing for greater speed and agility. They developed a remarkably efficient respiratory system, one that allowed them to extract more oxygen from the thin air. They were a new and improved design, perfectly suited to the harsh conditions of the recovering world. Our own ancestors, by contrast, did not fare so well. They were slowly outcompeted, pushed into the margins of the new ecosystems. The age of mammal-like reptiles was over. A new age, the age of dinosaurs, was dawning. For the next 150 million years, our own lineage would be relegated to the shadows, surviving as small nocturnal shrew-like creatures, scurrying at the feet of giants. The world belonged to the dinosaurs. They would grow to sizes that defy the imagination and dominate every continent, becoming the undisputed masters of the planet. This long and successful reign is, of course, a testament to their brilliant evolutionary design. But in the quiet contemplation of our journey, we can allow ourselves to see it in another light. Let us consider the perspective of the gardeners, the planetary stewards reeling from the catastrophic failure of the great dying. Their first great experiment in complex life had been brought to ruin not by an external blow, but by the planet's own inner turmoil. It is possible they would have concluded that their initial approach was flawed. Perhaps they saw the high-energy, warm-blooded metabolism of the mammal-like synapsids as inherently unstable, too demanding on a planetary system that had proven to be fragile. And so, in the aftermath, they made a different choice. They decided to back a new blueprint. The resilient, adaptable, and less metabolically demanding reptilian form may have seemed like a safer, more stable foundation upon which to rebuild the biosphere. They did not intervene directly, but perhaps they subtly altered environmental conditions to favor the archosaurs, giving them the slight evolutionary edge they needed to thrive. In this view, the age of dinosaurs was not an accident of evolution. It was Plan B. It was a 150 million year long experiment in reptilian dominance, a grand attempt to create a stable, enduring, and crisis-proof global ecosystem. For a time, it seemed to be a resounding success. The dinosaurs were a marvel of resilience, surviving and thriving through massive changes in climate and geography. The garden was growing again, wild and magnificent, filled with creatures of awe-inspiring scale and power. The gardeners, perhaps, allowed themselves a sense of relief. Their system had been rebuilt, and it was strong. And what of our own ancestors? They were not extinguished. They simply waited. In their long exile in the shadows, they honed the traits that would one day allow them to inherit the world. Warm blood, protective fur, keen senses of hearing and smell for navigating the night, and larger brains for outwitting the dangers of a world ruled by giants. They were a seed, lying dormant in the soil of a vast reptilian forest, waiting for the sun. Their story was not over. It had simply entered a long and patient pause. The 150 million year reign of the dinosaurs was a necessary chapter in the Earth's story, but it was not the final one. A different kind of creature was biding its time in the darkness, and its moment was yet to come. For 150 million years, the world echoed with the footfalls of giants. The dinosaurs, in their magnificent diversity, were the undisputed masters of the earth, and during this long sunlit reign, our own ancestors remained creatures of the periphery, of the night. In the story of the world, they were a footnote, but while their bodies remained small and hidden, another story was unfolding, one written not on the face of the planet, but in the deepest recesses of the cell. While the dinosaurs ruled the day, the mammalian genome was being quietly edited in the dark. Let us return to that living library within us, the vast and ancient text of our DNA. We often think of it as a pure lineage, a sacred text passed down from our earliest ancestor. But the reality is far stranger and more complex. Our genome is a collage, a scrapbook of deep time filled with insertions, edits, and messages from other forms of life. One of the most startling discoveries of modern genetics is that at least 8% of our DNA is made of the ghosts of ancient viruses. They are called endogenous retroviruses. These are the remnants of infections that afflicted our distant ancestors millions of years ago. A virus, in its quest to replicate, will sometimes insert its own genetic code into the DNA of its host. If this happens to occur in a reproductive cell, a sperm or an egg, that viral code can be passed down to the next generation, and the next, until it becomes a permanent, silent fixture in the genetic heritage of a species. Our DNA is a graveyard of these ancient plagues, a record of the viral wars our ancestors survived. Most of this viral code is disabled and inert, the meaningless graffiti we spoke of earlier. But some of it has been co-opted by our own biology, repurposed to serve new functions. This reveals a profound truth. The genome is not a sealed vault. Information can be inserted from the outside. If a simple virus can write itself into the book of life, it forces us to ask a deeper question. If our hypothetical gardeners wish to add a new chapter, a new set of instructions, to their chosen lineage, a sophisticated virus-like delivery system would be an elegant and effective tool. This thought becomes even more compelling when we consider another of the genome's great mysteries, the ultra-conserved regions. These are long stretches of DNA, sometimes hundreds of letters long, that are perfectly identical, or almost identical, across hundreds of millions of years of evolution. We can find a sequence in the human genome that is exactly the same in the genome of a mouse, a dog, and even a chicken. This is statistically breathtaking. Over such vast timescales, DNA should naturally accumulate random mutations and change. For these regions to remain perfectly frozen, unchanged for 300 million years, means that they are being protected by natural selection with a ferocity that is almost absolute. Any change, any single letter altered, must have been so detrimental that the organism did not survive to pass it on. This implies these sequences are performing a function so vital, so fundamental, that it cannot be altered. And yet, many of them do not code for proteins. They lie in the so-called dark matter of the genome, their purpose a profound and tantalizing mystery. What if these regions are more than just genetic switches? What if they are the very instructions we have been searching for? Let us imagine that long ago, the gardeners inserted a kind of core software into the mammalian line, a compressed archive of potential. For 150 million years, while our ancestors scurried through the darkness, this archive was silently carried, protected from change by an unknown but powerful biological function. It was an inheritance, waiting for a future it could not yet see. This reframes that long period of waiting. It was not just a struggle for survival, it was an act of preservation. The small nocturnal mammal was the perfect vessel to carry this precious genetic cargo through a dangerous world. Its humble lifestyle kept it safe, while deep within its cells, this ghost in the DNA, this ancient and mysterious code, was being guarded and passed down, ready for the day the age of giants would come to a close and a new kind of mind would be asked to grow. The age of reptiles was a resounding success. For 150 million years, the dinosaurs and their kin had proven to be a stable and enduring foundation for the planet's biosphere. They had weathered ice ages, continental shifts, and fluctuating sea levels. From the perspective of any observer, their dynasty must have seemed eternal, their reign a permanent feature of the world. The garden, rebuilt after the Great Dying, was once again lush and magnificent, a testament to the resilience of life and, perhaps, to the patient stewardship of its silent keepers. The great experiment of Plan B was, by all measures, complete. And then, on an otherwise ordinary day, 66 million years ago, a messenger arrived from the void. It was a rock, 6 miles wide, traveling at a speed too fast for the mind to truly comprehend. It had journeyed for billions of years through the cold and the dark of the solar system, and its path was destined to intersect with the Earth. This was not a slow sickness from within the planet, like the one that had caused the Great Dying. This was a sudden, violent, and entirely random blow from the heavens. The impact itself, in the shallow waters off the coast of modern-day Mexico, was an event of unimaginable power, unleashing more energy than all the world's nuclear weapons combined. But it was the aftermath that remade the world. A cloud of pulverized rock, soot, and dust was thrown into the upper atmosphere, and it quickly spread, wrapping the entire planet in a dark shroud. The sun, the source of all energy and life, was blotted out. For months, perhaps for years, a deep and chilling twilight fell upon the surface of the earth. A long winter began. Without sunlight, the plants withered and died. The great forests collapsed. The plankton in the oceans vanished. The entire global food chain, built upon the foundation of photosynthesis, was severed at its root. For the dinosaurs, the great sun-powered engines of the Cretaceous world, it was a death sentence. The large herbivores starved first, and the carnivores who hunted them soon followed. The cold-blooded reptiles, so well adapted to a warm and stable world, could not survive the deep, lingering chill. The long and glorious age of dinosaurs came to a sudden, ignominious end. Their reign was not ended by a rival, but by a rock. From the perspective of our hypothetical gardeners, what could this moment have been? Were they, for the second time, helpless witnesses to a catastrophe? Did they watch in dismay as their carefully rebuilt garden was shattered by a single senseless act of cosmic chance? It is a poignant image, a consciousness that works on scales of eons, brought to ruin by the bad luck of a single moment. It would suggest that for all their wisdom and power, they too are subject to the indifferent and often violent mechanics of the universe. But in the quiet of our journey, let us allow for another, more unsettling possibility. What if it was not an accident? What if, after 150 million years, the gardeners had concluded that their dinosaur experiment, for all its stability and magnificence, had reached its evolutionary end? The dinosaurs were a marvel of physical adaptation, but perhaps they showed no sign of developing the one trait the gardeners were truly waiting for, a higher, abstract consciousness. What if the garden had become a beautiful, but ultimately stagnant museum? From this chilling perspective, the asteroid was not a random catastrophe. It was a tool. It was a controlled burn, a necessary act of destruction to clear the way for something new. It was the most ruthless act of gardening imaginable, the felling of a great and ancient forest so that a small promising seed, long dormant in the soil, could finally have its chance at the sun. This thought adds a layer of profound and troubling ambiguity to our silent stewards. It recasts them not just as gentle cultivators, but as unsentimental, and perhaps even cruel architects of destiny, willing to erase a masterpiece to make way for what they hoped would be a greater one. We cannot know. We can only look at the result. In the cold and the dark of the long impact winter, as the giants of the earth fell silent one by one, a different kind of creature was uniquely suited to survive. The small warm-blooded mammals, our ancestors, who had spent 150 million years honing their skills in the shadows, were prepared. Their fur protected them from the cold. Their small size meant they needed less food. Their diet of insects, roots, and seeds allowed them to survive on the world's decaying leftovers. The long night that ended the age of dinosaurs was the very dawn of the age of mammals. The world was empty once more, and this time it was theirs to inherit. The long winter passed. Slowly, tentatively, the sun returned to a wounded and quiet world. The great engines of reptilian life were silent, and the garden, though scarred, was now empty of its former masters. From the burrows and the undergrowth, from the twilight world where they had endured for 150 million years, our ancestors emerged. They were the children of the long night, inheriting a world that was, for the first time, theirs. What followed was an explosion of evolutionary creativity that rivaled the Cambrian explosion in its speed and scope, but this time it was a mammalian story. With the dinosaurs gone, a planet's worth of ecological roles lay vacant. It was a world of opportunity, and our ancestors seized it with breathtaking speed. For millions of years they had been small, shrew-like creatures, locked in a single, humble form. Now, released from their constraints, the mammalian blueprint began to unpack itself, diversifying into 1,000 new forms. Within just 10 million years, a heartbeat in geological time, the world was filled with mammals. Some grew to enormous sizes, becoming the new titans of the land, great lumbering herbivores, and the fearsome predators who hunted them. Others took to the air, their fingers elongating into delicate wings, becoming the first bats and mastering the night sky in a way the dinosaurs never had. And in one of the most remarkable evolutionary journeys of all time, some mammals, descended from hoofed land-dwelling creatures, turned their back on the shore and returned to the sea. Over generations, their legs receded, their bodies streamlined, and they became the first whales, claiming the oceanic thrones that the great marine reptiles had vacated. This was the dawn of the Cenozoic, the age of mammals. It was a resounding and total victory for the creatures of the shadow. From a scientific perspective, it was a classic case of adaptive radiation, a story of the right creatures being in the right place at the right time. But in the context of our grand, quiet speculation, it feels like something more. It feels like the culmination of a plan. Let us revisit our gardeners. Whether the asteroid was a tragic accident they endured or a ruthless tool they employed, the result was the same. The board was cleared. Now the lineage they had, perhaps been cultivating all along, the one whose genome they may have secretly edited and protected, was finally given its chance. This was the moment for warm blood, for fur, for the close bond between mother and child, for the larger brains that had been developed to navigate a dangerous world. These were not just random traits. Perhaps they were the very qualities the gardeners believed were necessary for the eventual evolution of empathy, of society, of consciousness. The incredible speed of the mammalian takeover suggests a deep and ready potential. It was as if the blueprints for all these new forms, for the bat, the whale, the tiger, the horse, were already sketched out in those mysterious, ultra-conserved regions of the genome we spoke of. The genetic software, carried silently for 150 million years, was finally being run. The environmental trigger, the absence of dinosaurs, allowed this pre-written potential to unfold and express itself, filling the empty world with a new kind of life. A life that was more energetic, more adaptable, and perhaps more intelligent than what had come before. The long patience of the gardeners, if they still existed, was finally being rewarded. The reptilian dynasty had been a magnificent but ultimately stagnant chapter. Now the story of life was accelerating once more, moving in a new and promising direction. Among the sprawling branches of this new mammalian family tree, one group in particular is of interest to our own story. They were small, clever creatures that took to the nurturing canopy of the recovering forests. In the trees, they developed grasping hands to move through the branches, and their eyes, once adapted for the night, slowly moved to the front of their faces, giving them a new stereoscopic view of the world. These were the first primates, and in their journey, a new kind of mind was beginning to take shape, one that would eventually learn to look not just at the branch in front of it, but at the stars above. For tens of millions of years after the fall of the dinosaurs, the world of our primate ancestors was a garden of breathtaking abundance. In the great tropical forests that girdled the Earth's equator, they lived a life of three-dimensional grace. Their world was a sea of leaves, an endless shifting canopy of branches and vines. Their minds were shaped by this world, by the need to remember the location of fruit trees, to navigate complex social groups, and to judge the distance of a leap from one branch to the next. It was a stable and successful existence, a long and peaceful childhood for our lineage. But the Earth is never still. The great slow engine of plate tectonics was at work, and on the continent of Africa, a vast rift was tearing through the landscape, pushing up great mountain ranges. This geological upheaval, combined with a gradual global cooling, began to change the climate. The mountains of the Great Rift Valley blocked the moist winds from the ocean, and a great drying began. The endless uniform sea of green began to break apart. The rainforest, the nurturing cradle of our evolution, was shrinking. In its place, a new landscape was spreading. The savanna, a vast ocean of grass, dotted with islands of trees. For the creatures of the canopy, this was a profound crisis. The world that had shaped them for millions of years was disappearing. The distance between one patch of forest and the next grew ever wider, the journey across the open ground more necessary and more dangerous. A choice had to be made: retreat with the shrinking forests, or adapt to the new open world. Our ancestors chose to adapt. They began the slow, hesitant journey down from the trees. This was perhaps the single most consequential step in our entire evolutionary history. To leave the safety of the branches for the exposed plains was to enter a world of new and terrible dangers, a world of powerful predators from whom there was nowhere to hide. But it was also a world of new opportunities. To survive on the savanna required a new way of being. And the first step was a new way of moving. Our ancestors stood up, and they began to walk on two legs. The evolution of bipedalism is one of the foundational mysteries of our origins. Scientists still debate the precise reason for it. Perhaps it was to see over the tall grass, to spot predators or distant resources. Perhaps it was to free the hands to carry food back to a home base. Or perhaps it was simply a more energy-efficient way to travel the long distances between one grove of trees and the next. Whatever the reason, this one anatomical change set in motion the entire story of humanity. From the perspective of our silent gardeners, this moment must have been one of supreme importance. Was this climate change, this breaking of the forest cradle, an event they simply observed and took advantage of? Or was it, like the asteroid, another deliberate act of cultivation? Did they understand that the comfortable paradise of the rainforest would never produce the kind of mind they were waiting for? That true innovation is born not from comfort, but from crisis. By forcing our ancestors onto the savanna, they were placing them in a crucible. The challenges of this new world would demand a new kind of intelligence. It would require complex social cooperation to protect the group from predators. It would demand better communication, better planning, and a deeper understanding of the landscape. And most importantly, by forcing our ancestors to walk upright, they freed the hands. These hands, which had for so long been used only for climbing and grasping branches, were now liberated. They were free to carry infants, to gather more food than could be eaten at once, and in time, they would be free to pick up a stone, to see in it the potential for a tool, and to strike it against another, making the first deliberate spark of a new kind of consciousness on Earth. The act of standing up was the end of one story, the long, quiet childhood in the trees, and the beginning of another, a story of struggle, of innovation, and of a mind slowly awakening on the vast, sunlit plains of Africa. the hands were free. For millions of years after our ancestors stood up, these remarkable instruments were used for carrying, for digging, for gesturing, for holding their young. They were an advantage, a useful adaptation to life on the plains. But they held a potential that was far deeper, a potential that would lie dormant until a new kind of connection was made, not in the hand, but in the mind behind the hand. Imagine a small hominin, perhaps 2.5 million years ago, sitting on the dusty African savanna. They are surrounded by the remnants of a predator's kill, the bones of a great antelope picked clean of its meat. Inside those bones is the marrow, a rich and fatty source of calories, but the bone is too strong to be broken by teeth or fists. Our ancestor picks up a smooth, rounded cobblestone. They have held stones like this 1,000 times, but this time, a new thought flickers into being, a spark of foresight. They see not just the stone in their hand and the bone on the ground, but a connection between them. They see a future that does not yet exist, a future where the bone is broken. In that moment of insight, technology was born. Our ancestor strikes the bone with the stone, breaking it to get the marrow. Later, another, even more profound leap occurs. They realize that by striking one stone against another, they can shape it, breaking off a sharp flake, creating a cutting edge where none existed before. This was not just using an object, this was making one. These first tools, what we now call the old one industry, were simple choppers and flakes. They were not beautiful, but they were the first physical objects on Earth to be born from a purely abstract idea. They were the mind imposing its will upon the raw material of the world. This invention was the key that unlocked a new future for our lineage. These simple, sharp stones gave our ancestors access to a new world of energy. They could now butcher carcasses, scraping meat from bone and, crucially, breaking those bones for the marrow within. This new energy-rich diet was a caloric revolution, and it provided the fuel for the most energy-hungry organ of all, the brain. A large brain is a great evolutionary luxury. It consumes an enormous amount of calories just to maintain itself. For our lineage to afford a bigger brain, it needed a richer diet. The invention of the stone tool provided that diet. And so began the most powerful feedback loop in the history of life on Earth. Better tools led to better food, which fueled the growth of a larger, more complex brain. A larger brain could then conceive of and create even better, more sophisticated tools. Hand, tool, food, and mind, all pushing each other forward in a spiral of accelerating change. From the perspective of our cosmic gardeners, this must have been the moment of breathtaking fulfillment. This was the process they had been waiting for. The environmental crisis of the shrinking forests had forced a change in posture. The change in posture had freed the hands, and the freed hands, guided by a curious mind, had now found their true purpose: to craft, to create, to remake the world to suit their needs. The entire grand project, from oxygenating the atmosphere, to enduring the long quiet, to clearing the board of its reptilian masters, had all been leading to this. The garden was no longer just the external biosphere of the planet. A new garden was now beginning to grow within the skull of this small, upright ape. The ultra-conserved genetic code, the ghost in the DNA we spoke of, may have been the very scaffolding for this new neural architecture. The potential, so long dormant, was finally being expressed. The mind was beginning to awaken, fueled by the very technology it was now creating. This new, larger brain would not just think of food and tools. It would begin to look at the world differently. It would see patterns. It would remember the past and plan for the future. It would look at the stars in the night sky, and for the first time it would wonder. The journey from this first simple stone tool to the cities and technologies of our modern world is a long one. But the path was now set. The Rubicon had been crossed. The mind of our ancestor was no longer just a mirror reflecting the world. It was becoming a lamp, ready to cast its own light. The thinking hand had remade the stone. The feedback loop of tools and food was now patiently reshaping the hominin brain, which was growing in size and complexity with each passing generation. Our ancestors were becoming more clever, more resourceful. But for all their dawning intelligence, they remained vulnerable. They were not the strongest nor the fastest creature on the savanna. Their greatest trial was the coming of night. The darkness belonged to the great predators, to the hunters with eyes that could see in the gloom. For our ancestors, night was a time of fear, a time for hiding. But there was another force on the savanna, one that all creatures, great and small, feared even more than the deadliest predator. It was fire, a destructive, unpredictable, and terrifying power. A lightning strike on the dry grass could turn a horizon into a wall of flame in minutes, sending every living thing fleeing in panic. For millions of years, the instinct was the same for all animals. When you see the fire, you run. And then, one of our ancestors did not. We will never know how or when it happened. The evidence for the first controlled fire is one of the most difficult things to find in the archaeological record. But we can imagine the moment. A lone hominin, perhaps of the species Homo erectus, observing the aftermath of a bushfire. Instead of just fear, they feel a spark of curiosity. They notice the warmth the smoldering embers provide against the night's chill. They see that no predator dares to come near the lingering glow. They see the roasted carcasses of small animals caught in the blaze. And a connection is made. Fire is not just a destructive force, it is a tool. It is power. The leap from this observation to the act of taming fire is one of the most profound in our history. It was an act of incredible bravery and foresight to approach the flame, to capture a burning branch, to carry it back to the safety of a cave, and, most difficult of all, to learn how to keep it alive. This was not just the use of a tool. It was the domestication of a force of nature. It was the moment our lineage stole a spark from the gods. The consequences of this act were immediate and revolutionary. The night was conquered. The campfire became a circle of light and warmth, a fortress against the predators of the dark. The hours of waking life were extended, and in the safety of the firelight, a new kind of social world was born. The hearth became the first living room, a place to gather, to share food, to mend tools, and perhaps, in the flickering shadows, to begin sharing the first stories. Beyond this social revolution was a biological one. Our ancestors began to use the fire to cook their food. This was another monumental innovation. Cooking does what our own stomachs do. It begins to break down tough fibers and complex proteins before the food is even eaten. It unlocks calories and nutrients that would be indigestible in their raw form. It neutralizes toxins in plants. The fire became a kind of external stomach, pre-digesting our meals for us. This new, incredibly efficient way of getting energy had a dramatic effect on our evolution. With more calories available, the still-growing brain was given the superfuel it needed for its final expansion. And because cooked food was so much softer and easier to chew, our bodies began to change. Our jaws grew smaller, our teeth less formidable, and our digestive tracts shorter. We were outsourcing our digestive work to the fire, and the energy saved was being rerouted to the 3 pounds of hungry neural tissue inside our skulls. From the quiet perspective of our gardeners, this was a critical threshold. The mastery of fire demonstrated a new level of consciousness. It was a triumph of intellect over instinct. It showed an ability to see beyond immediate danger and recognize a deeper potential. It was the first time their subjects were not just shaping matter, but harnessing energy. This was the final catalyst, the last great push that would propel the hominin mind toward the threshold of self-awareness. The gentle, warming glow of that first campfire was the light of a new dawn, and in its circle of safety, the mind that would one day name the stars was being born. The final pieces were in place. The body was upright, the hands were free, and the mind was now nourished by the transformative power of fire. For hundreds of thousands of years, our species, Homo sapiens, shared the earth with other kinds of humans. We possessed the same large brains, the same skillful hands. We were expert toolmakers, hunters, and survivors. We were, by any measure, a remarkably successful animal. But we were still just that, an animal, living almost entirely in the present moment, reacting to the world as it was. The greatest revolution was yet to come, and it would happen not in the body, but in the silent 3-pound universe of the brain itself. Sometime around 70,000 years ago, something changed. The archaeological record, which had been fairly static for a very long time, begins to show signs of a new and restless creativity. We see the first unambiguous evidence of art, pieces of ochre engraved with geometric patterns. We find the first jewelry, seashell beads, carefully drilled and strung together, that could have served no purpose other than adornment or identity. And a little later, deep in the darkness of caves, we find the breathtaking paintings of animals, rendered with a skill and sensitivity that still moves us today. This was not just a technological advancement, it was the dawn of a new kind of consciousness. This is the evidence of a mind that was no longer just a mirror, passively reflecting the outside world. It had become a lamp, capable of generating its own inner light. The creation of a necklace or a painting is a profoundly symbolic act. It shows a mind that is thinking about things like beauty, identity, community, and spirit. It is the physical manifestation of an inner world, of dreams and ideas. Alongside this artistic explosion, we can infer the arrival of the final, crucial tool. Complex language, not just a language of warning calls and simple instructions, but a language that could tell stories, a language that could speak of yesterday and of tomorrow, of things that are not physically present, of ideas, of loyalties, of laws, of spirits and gods. This ability to communicate about a shared, imagined reality was our species' secret weapon. It allowed us to cooperate in ways never before seen on Earth, to form vast communities based on shared myths and beliefs, to plan for the distant future, and to pass down knowledge from one generation to the next with astonishing fidelity. What caused this great leap forward? Scientists debate whether it was a slow cultural evolution or the result of a sudden genetic mutation that rewired the brain. But in the quiet narrative of our gardeners, this moment appears as the grand finale, the final and most important activation. This was the true goal of their billions of years of patient work. The physical vessel was complete. The brain was large and powerful, and now the latent software that had been carried in our DNA for so long was finally booted up. The inherited potential preserved in those ultra-conserved regions of our genome was perhaps not for building a better body, but for building a symbolic mind, our instinct for art, for myth, for music, for spirituality. Perhaps these are the echoes of that ancient code finally expressing itself. The world of dreams became as important as the world of the hunt. We became the creature that lives not in one world, but two, the physical world outside and the boundless imagined world within. This new consciousness was the gardener's ultimate achievement. They had cultivated a creature that could not only survive and adapt, but could ask why. A creature that could look at its own reflection and have a sense of I. A creature that could look at the vast, silent cosmos from which the gardeners themselves perhaps came, and feel a sense of wonder. The long, slow, and often brutal process of evolution had finally produced an instrument that could, perhaps, understand its own music. The project was complete. The child had awakened. The question that remained was what it would do, now that it was finally aware of the garden and of itself. The awakening was complete. The human mind, with its unique capacity for symbolic thought and shared myth, was now the most formidable force on the planet. This new ability to cooperate flexibly in large numbers, bound together by stories, was a kind of superpower, and like any young power, it was first used to explore and to conquer. Armed with this new cognitive toolkit, Homo sapiens began to spread from our African homeland, a slow but inexorable wave of migration that would eventually cover every habitable continent on Earth. For the first time in 4.5 billion years, a single species of large animal would come to dominate the entire globe. But as our ancestors moved into new lands, they were not entering an empty garden. These continents were already home to ancient and magnificent ecosystems, populated by giant creatures, the megafauna, who had reigned for millions of years. Australia had giant kangaroos and wombats the size of rhinos. The Americas had mammoths, mastodons, giant ground sloths, and saber-toothed cats. As our small bands of human hunters arrived, equipped with their sophisticated tools, coordinated strategies, and an intelligence these animals had never before encountered, a tragic pattern emerged. The great beasts vanished. This was the first planetary-scale mark of our new consciousness, a wave of extinctions that swept across the globe in our wake. It was not born of malice, but of stunning efficiency. Our minds had made us the most successful predator the world had ever seen, and the ancient, slow rhythms of the garden were unprepared for such a novel and disruptive force. This was only the beginning. For tens of thousands of years, we remained hunters and gatherers. But then, in another profound shift, we learned to domesticate plants and animals. With the agricultural revolution, we were no longer just living in the garden. We began to actively redesign it for our own purposes. We cleared vast ancient forests to make way for fields of a few chosen crops. We altered the paths of rivers. We favored a handful of species we found useful and pushed countless others toward oblivion. We were beginning to consciously, though perhaps not wisely, take control of the biosphere. And now, in the last few centuries, with the power of industry, our impact has become a truly geological force. We have reached the point where scientists have proposed a new name for our chapter in the Earth's history: the Anthropocene, the age of humans. We are now the primary drivers of planetary change. We are altering the composition of the atmosphere, much like the first cyanobacteria did, but at a speed that is thousands of times faster. We are changing the chemistry of the oceans. Our activities are triggering a mass extinction event that may one day rival the great dyings of the deep past. From the vast, silent perspective of our hypothetical gardeners, what must this look like? For billions of years, they had patiently, carefully cultivated the Earth's systems, aiming for a delicate and enduring balance. Now, their chosen inheritor, the creature whose consciousness they had so carefully nurtured, is repeating their great acts of planetary engineering, but as a chaotic and uncontrolled echo. Their great oxygenation event was a slow multi-million-year project. Our alteration of the atmosphere is the work of 2 centuries. Their management of the biosphere created diversity. Our management creates monocultures and extinctions. It is as if a child has been shown a masterpiece of clockwork, and instead of studying its delicate balance, has simply wound all the springs as tightly as they will go, just to see what happens. We have, it would seem, inherited their power without yet understanding their patience or their purpose. We have become a planetary force, but we are a young and reckless one, driven by short-term needs and a consciousness that struggles to comprehend the deep geological time in which our actions will ultimately be judged. The question that hangs in the quiet air of our modern world is whether this uncontrolled echo is simply the sound of a young intelligence learning to use its voice, or if it is the sound of a beautiful, ancient instrument being broken, unaware of the long silence that may follow. To understand the chaotic nature of our planetary impact, we must look to the nature of the mind that is causing it. The uncontrolled echo of the Anthropocene is a direct reflection of the kind of consciousness that we, as Homo sapiens, possess. It is a form of awareness that is, as far as we know, unique in the history of our world, and it stands in stark contrast to the hypothetical mind of the gardeners we have been imagining. Let us first consider our own consciousness. It is a brilliant, beautiful, and powerful thing, but it is also a firefly consciousness. a bright and flickering spark that experiences the world in frantic, intensely personal bursts. Our minds are built on the scale of a single human lifetime. We think in terms of days, seasons, and years. Our brains evolved to solve immediate problems, to find the next meal, to avoid the predator in the grass, to navigate the complex social dynamics of a small tribe. We are storytellers, wired for narrative, for drama, for beginnings, middles, and ends. This makes us astonishingly creative and adaptable, but it also makes us profoundly short-sighted. We struggle to feel the reality of a threat that is a century away. A geological eon is, to us, a meaningless abstraction. Our consciousness is also fiercely individual. The sense of a separate I, a singular ego at the center of our own personal story, is the bedrock of our experience. While we are capable of great empathy and collective action, our fundamental perspective is that of a single fleeting self trying to make its way in a vast and indifferent world. We are a collection of 7 billion individual stories, each burning brightly for a few decades before winking out. Now, let us try to imagine the consciousness of the gardeners. If it existed, it must have been of a completely different order. It would have been a geological consciousness. It would not think in years, but in epochs. Its thoughts would not be fleeting sparks, but the slow, immense grinding of tectonic plates. Its awareness would not be centered in an individual ego, but would be diffuse, collective, perhaps woven into the very fabric of the biosphere itself, like a planet-spanning mycelial network. Its sense of self would not be I, but we, with the we, encompassing the entire living world. The great projects we have ascribed to them, the oxygenation of the atmosphere, the long stabilization of the boring billion, the clearing of the board for the age of mammals, were not 5-year plans. They were 100-million-year plans. To a mind like that, a mass extinction might be viewed as a necessary, if tragic, form of planetary surgery. To our firefly minds, it is an unthinkable horror. So why? Why would a slow, collective, geological consciousness go to the trouble of cultivating its very opposite? Why spend billions of years of patient, stabilizing work to produce a fast, individual, and deeply destabilizing intelligence? Perhaps this was the ultimate goal, to create a new kind of consciousness, one that could bring the gifts of speed, of creativity, of individuality to the cosmos. Perhaps our role is not to be stable, but to be the agents of radical, unpredictable change. Or perhaps in this grand project, they made a profound miscalculation. Perhaps in nurturing the seed of self-awareness, they accidentally created a mind that is constitutionally incapable of seeing the larger garden for the beauty of its own individual flower. It is a somber thought that our consciousness, for all its glory, is fundamentally incompatible with the long-term health of the planetary system that created it. That we are a brilliant but fatal experiment. The great challenge of our time, the central question of the Anthropocene, is whether we can bridge this gap. Can our fast, storytelling minds learn to think on slow geological timescales? Can our individual, ego-driven consciousness develop a true and lasting sense of a collective self, one that includes the entire community of life? We have inherited the power of a planetary force, and our great, perhaps final task is to see if we can also develop a planetary wisdom. Our own consciousness, it seems, is a double-edged sword. It grants us the power to reshape a planet, but it also traps us within the fleeting timescale of a single life. The great challenge of our age is to learn to see the world through the lens of deep time, to temper our frantic short-term actions with a longer, wiser perspective. Perhaps the first step in learning to think like a gardener is to search for the records of their work, to look for their lessons not just in our past, but in the world around us now. Our search, which began in the ancient pages of rock, must now turn to new and far more subtle libraries. Let us travel first to the coldest and most desolate place on Earth, the high plateau of Antarctica. Here, the world is a sculpture of wind and ice. For nearly 1 million years, snow has fallen, never melting, compressing under its own immense weight into a sheet of ice 2 miles thick. This ice is a perfect frozen archive of the Earth's atmosphere. By drilling deep into it, we can pull up cores of ice that are like transparent tree rings, allowing us to travel backwards in time. Trapped within the ice are tiny pristine bubbles of ancient air, samples of the Earth's breath from millennia ago. In this frozen library, we have read the story of the great ice ages. We have found layers of volcanic ash from distant eruptions. We can see the first faint traces of our own industrial pollution. The question we must now ask is, what else might be hiding in the deepest, oldest layers? Could there be a trace of a complex synthetic molecule that has no natural origin? A sudden, inexplicable spike in an isotope, unrelated to any known geological event. If an ancient civilization had a global atmospheric effect, however brief, its signature might be waiting for us, perfectly preserved, in the silence of the Antarctic ice. From the frozen surface, let us now journey to the deep, fiery heart of the oceans. Here, along the mid-ocean ridges, are hydrothermal vents, great volcanic chimneys spewing superheated mineral-rich water from the Earth's mantle. In the crushing pressure and total darkness, life still thrives, but it is a different kind of life. It does not run on sunlight, but on chemistry. This is the deep biosphere, an ecosystem that is almost entirely separate from our world on the surface. Some scientists believe that life may have even originated in places like this. These deep, dark ecosystems have been stable for immense periods of time, shielded from the catastrophes that have occasionally racked the surface world. Could these oases of ancient life be a kind of biological sanctuary? Could the extremophile microbes that live here carry a purer, less edited version of the genetic code? Perhaps here in the DNA of these deep organisms, we might find a clearer version of the watermark, the ghost in the DNA, that has been obscured by the chaotic evolution of life on the surface. It may be a genetic Rosetta Stone waiting in the planet's most inaccessible depths. Finally, our search must take its most ambitious leap. It must move beyond the physical, beyond even the biological, and into the realm of pure information. What is the most durable medium in the universe? It is not stone or ice or even DNA. It is the fabric of space-time and the fundamental laws of physics themselves. If a truly ancient and advanced intelligence wanted to leave a message that would last for eternity, it would not build a monument. It would weave its message into the statistical noise of the cosmos. Could there be a subtle, artificial pattern hidden in the faint afterglow of the Big Bang, the cosmic microwave background? Could the fundamental constants of nature, the speed of light, the strength of gravity, be tuned with a precision that is statistically unlikely to be an accident? This is the ultimate frontier of our search. It is the idea that the universe itself might be the final message. We are no longer looking for a fingerprint left on the world. We are looking for the signature of the author in the text of reality itself. We may not yet have the scientific language to read such a message, but the very possibility fills us with a profound and humbling awe. The clues to our deepest past may not be behind us, but all around us in the coldest ice, in the deepest life, and in the silent hum of the void. Our search has taken us from the stone beneath our feet to the ice at the poles, and even to the silent hum of the cosmos. As we seek out these faint and scattered clues, we are drawn towards a profound and unifying idea, a scientific hypothesis that resonates deeply with the story we have been telling. It is the idea that our planet is not just a rock that happens to host life, but that the planet and all of its life together form a single, vast, self-regulating system, a living entity in its own right. This is the Gaia hypothesis. Proposed in the modern era by a scientist and a microbiologist, the idea of Gaia invites us to see the Earth as a single, integrated organism. Just as your own body works unconsciously to maintain a stable temperature and chemical balance, The Gaian idea suggests that the biosphere as a whole actively manages and maintains the conditions that are favorable for life. It is a radical shift in perspective. The oceans, the atmosphere, the forests, and the soil are not just a passive environment. They are functioning parts of a single planetary scale body. We see the evidence of this self-regulation everywhere. For hundreds of millions of years, the sun's output has gradually increased, yet the Earth's temperature has remained remarkably stable within the narrow band required for liquid water. The oxygen content of our atmosphere is maintained at a steady 21%, a perfect but precarious balance. Life is not a passive passenger on this planet. It is in the driver's seat. The growth of plankton in the oceans can influence cloud formation and global climate. The spread of forests can alter rainfall patterns. It is a system of immense complexity, a silent, interconnected dance of feedback loops that has sustained the miracle of life for eons. The central debate around this idea has always been about consciousness. Is this self-regulation simply an emergent property of a complex system, an automatic and mindless process? Or does it imply a form of intent, a planetary scale awareness? Here, our speculative journey finds its most elegant connection. What if the Gaia we see today, this beautiful, resilient, but seemingly unconscious system, is the legacy, the great silent machine left behind by our gardeners? Let us propose that the precursor civilization was the Gaian mind. They were not just stewards living on the earth. Their consciousness was the earth. Their thoughts were the slow biogeochemical cycles. Their technology was the intricate feedback loops between life and the environment. When they undertook the great oxygenation, they were not terraforming a foreign world. They were consciously changing their own body. The long, stable quiet of the Boring Billion was a period of deep planetary meditation, a time of consolidating and perfecting this new metabolism. From this perspective, the Gaian system is the masterpiece they built. It is a life support system so perfectly designed, so deeply integrated, that it no longer requires a conscious mind to operate it. It runs on a kind of planetary instinct, a set of deeply encoded reflexes. The gardeners, their work complete, have vanished, but their living creation endures. We are living inside their great abandoned project, a garden that still remembers how to tend to itself. This reframes our own emergence in a powerful new light. We, with our new individualistic firefly consciousness, are like a novel thought arising in a vast sleeping mind. We are the first part of this ancient system to develop self-awareness in a new way, to become a mind within the mind. Our current chaotic impact on the planet is the thrashing of this new consciousness as it awakens, not yet aware that it is a part of a much older, much larger, and far more delicate body. The path to wisdom, then, is not about conquering nature or even about becoming its stewards. It is about remembering. It is about reintegration. Our great task is to learn to listen to the ancient, slow rhythms of the Gaian system we are a part of, to harmonize our own fast, brilliant, and dangerous consciousness with the deep, instinctual wisdom of the living planet. We are the waking mind of the world, and our most profound challenge is to learn the language of the body we inhabit. If we are, as our journey has led us to wonder, the waking mind of a living planet, then this knowledge is more than just a scientific curiosity. It is a revelation that carries with it a profound and inescapable responsibility. To accept this possibility, even as a thought experiment, is to fundamentally change our relationship with the world and our place within it. It is the responsibility of remembering. For all of our history, we have seen the earth as a stage upon which our human drama unfolds. It has been our resource, our provider, our home, and sometimes our adversary. But it has always been the passive backdrop to our own story. The realization that the stage itself might be the main character, a multi-billion-year-old intelligence, of which we are only the most recent expression, changes everything. It means we are not the first conscious beings on this planet. only the first in a very long time to be self-aware in this particular individualistic way. This knowledge carries a great burden. It means that every disappearing species, every acre of cleared rainforest, every ton of carbon poured into the air is not just an environmental problem to be managed. It is an act of forgetting. It is the tearing out of a page from the most ancient library in existence. It is the silencing of a voice in the planetary symphony. The current extinction crisis is no longer just a tragedy. It becomes an act of cosmic vandalism, the erasure of the living memory of our own Creator. We are eroding the very mind that gave us birth. But this responsibility is also a profound gift. It offers us a purpose, a grand and unifying narrative that transcends all our smaller divisions of nation, tribe, and creed. If we are the inheritors of this ancient Gaian system, then our purpose is clear. We are to be its guardians. We are to be the curators of this planetary masterpiece. Our great work is to transition from being the planet's reckless child to its conscious and responsible heir. The ultimate goal of our science, our philosophy, and our spirituality would be to understand the workings of this vast living system, not just to exploit it, but to protect and harmonize with it. This shifts our role from that of a steward to something more. A steward is a temporary caretaker of something that belongs to another. An heir is a successor, destined to one day take on the role of the master. This idea suggests that our destiny is not simply to preserve the garden, but to learn how to become gardeners ourselves, to learn to wield our own immense technological and cognitive power with the same wisdom and foresight as our silent precursors. What then does it mean to remember them? It is not about excavating a ruin or finding an artifact. It is about learning to read the text of the Gaian system itself. It is the ecologist tracing the intricate web of life and seeing in it a form of distributed intelligence. It is the geologist reading the rock strata and understanding the slow, deep breathing of the planet. It is the astronomer looking to the heavens and understanding the cosmic context that makes our living world so precious. Remembering is an act of reconnection, of seeing the intelligence that is not in a faraway alien object, but in the soil, the sea, the air, and in the very DNA that connects us to every other living thing. Perhaps this was always the final stage of the gardener's plan. A self-regulating system, however perfect, is still vulnerable to external shocks from the cosmos. Perhaps a truly resilient planet needs a new component, a fast, creative, problem-solving consciousness that can anticipate and react to novel threats. Our purpose upon remembering our heritage might be to become the new nervous system for the sleeping Earth, to be its eyes and its hands, to protect it from the next asteroid, and to guide its long journey into the cosmic future. This is the responsibility of remembering, to finally see our home for what it is, and in doing so, to finally understand ourselves. If we accept the responsibility of remembering, of becoming the conscious heirs to a living planet, then our first and most humble task is to learn how to listen. We must quiet the loud, insistent monologue of our own firefly consciousness and attune our senses to a much older and more subtle voice. The Gaian mind, the legacy of our silent gardeners, may no longer be a singular, unified consciousness, but its echoes, its faint and beautiful whispers, are still all around us. We have only forgotten how to hear them. We search for a voice like our own, a signal we can easily recognize. But the language of Gaia is not spoken in words. It is spoken in patterns. It is the language of complex, interconnected systems, of a mind that is not located in one place, but is distributed throughout the entire fabric of the living world. Consider for a moment a great flock of starlings at dusk, thousands of birds moving as one, a swirling liquid cloud in the evening sky. They wheel and dive in perfect, breathtaking synchrony, creating shapes that seem designed by a single artistic hand. Yet there is no leader. There is no conductor orchestrating this aerial ballet. The intelligence that guides the flock does not belong to any single bird. It is a shared mind, a swarm consciousness, an emergent property of thousands of simple interactions. This is one of the fast, visible whispers of Gaia. Journey with us now from the sky to the soil, beneath the floor of an old-growth forest. Here another, much slower mind is at work. The trees that seem to us like silent, solitary individuals are in fact deeply interconnected. They are bound together by a vast subterranean network of fungal threads, a mycelial web that has been called the Wood Wide Web. Through this living internet, the trees share resources. A great sunlit mother tree can send sugars to her shaded offspring. A tree under attack by insects can send chemical warnings to its neighbors. The forest is not a collection of trees. It is a community, a single complex organism with a slow chemical nervous system. This is the mind of the forest, a deeper, quieter whisper. Let us now zoom out to the scale of the entire planet. Watch the great, slow patterns of the ocean currents, the global conveyor belts that carry warmth and life around the globe. Observe the cyclical rhythms of the climate, like the El Niño phenomenon, a planetary scale pulse that shapes the weather for billions of beings. These are the deep thoughts of the planet. They are its circulatory system, its breath. To our short-lived consciousness, they often appear as chaos, as unpredictable weather. But within them is a deep, resonant, and self-regulating order. This is the heartbeat of Gaia, the slowest and most profound whisper of all. From the perspective of our gardeners, these patterns are the instincts they wove into the very code of the world. They are the beautiful, self-organizing processes they initiated, the remnants of their own holistic consciousness, now left to run on a kind of perfect, planetary autopilot. When we see the murmuration of the starlings or trace the hidden connections of the forest, we are seeing the faint, living echoes of their ancient mind. Our most important scientific and spiritual work, then, is to become students of these patterns. It requires a new way of seeing, a shift from focusing on individual objects to understanding the relationships between them. It asks us to quiet our own incessant need to control and manage, and to simply observe the world with a new and profound humility. The earth is not a silent machine. It is a living symphony of information, a constant, quiet song of interconnectedness. The signals are not lost. They are in the dance of the flock, the wisdom of the forest, and the rhythm of the tides. We are surrounded by them. We only need to be still and to listen. We have spent our journey listening for the faint whispers of an ancient mind within our own world. But now, in these final moments of our shared contemplation, let us lift our gaze one last time from the intricate patterns of the earth to the vast, silent canvas of the night sky. Our planet, for all its beauty and complexity, is but one small garden in a cosmos that contains billions upon billions of other potential gardens. And this thought leads us to one of the most profound and unsettling questions of our time. If the universe is so vast, where is everybody? This is the great cosmic silence. For more than half a century, we have been listening. We have built great radio telescopes, dishes turned to the heavens, straining to hear a single artificial signal in the cosmic static. We have scanned the stars for the telltale signs of alien technologies, for the footprint of a great interstellar civilization. And in all that time, from all that immensity, we have heard nothing. The universe, it would seem, is unnervingly quiet. This silence has troubled our thinkers, giving birth to all manner of dark and unsettling hypotheses. But perhaps the answer to this great silence is hidden in the very story we have been telling. We have been searching for a consciousness like our own, a young, expansive, technological firefly consciousness, eager to broadcast its existence and conquer the stars. We have been looking for an echo of ourselves. But what if our kind of mind is not the destination of intelligence, but only a brief and turbulent phase? Let us imagine for a moment that the path we have traced on Earth is not an anomaly, but a universal law. What if, on countless worlds across the galaxy, life emerges and with it, a guiding, planetary scale intelligence, a Gaian mind? And what if the ultimate goal of this intelligence is not to build starships, but to build a perfectly balanced, resilient, and conscious world? What if the pinnacle of civilization is not to leave home, but to become one with it? From this perspective, the universe is not empty. It is just very quiet. It is a cosmos filled with gardeners, a billion worlds where ancient, intelligent life has chosen a different path. A path of integration, not expansion. A path of biology, not mechanics. Their great works are not orbiting megastructures, but stable climates and thriving ecosystems. Their technology is not in radio waves, but in the silent, intricate language of their own planet's genetics. The great silence is not a sign of absence, but a sign of maturity. It is the sound of a universe that has learned to listen rather than to shout. This reframes the story of our own gardeners. They were not alien visitors in the way we imagine. They were simply the local expression of a cosmic imperative. The process that unfolded on our Earth was not a singular miracle, but a quiet, patient, and universal song that the universe sings to itself in the cradle of every suitable world. And it leaves us with one final, breathtaking mystery. If the cosmos is a forest of these quiet, living worlds, are they truly isolated? Or is there a form of communication that we, in our noisy infancy, cannot yet perceive? Perhaps there is a slow, silent conversation taking place all around us, a galactic network of Gaian minds speaking to each other not through radio, but through the gentle modulation of neutrinos, through gravitational waves, or through some deeper connection woven into the fabric of space-time itself. A conversation on a timescale so vast that a single sentence might take 1,000,000 years to utter. This perspective places our own restless, technological civilization in a new and humbling light. We may be one of the rarest things in the universe, a young intelligence still in its loud and chaotic phase. Our destiny may not be to join a federation of starfaring empires, but to one day quiet down, to complete our own journey of integration, and to take our place in the silent, cosmic chorus of living worlds. Our small blue planet is not just our home. It is our garden, our legacy, and our unique contribution to the vast and profoundly alive universe. And so, after a journey that has taken us from the deep geological past to the silent expanse of the cosmos, we find ourselves back where we began, in this quiet moment, in this shared space of wonder. We have traveled far, but our greatest discovery is a new way of seeing the ground beneath our feet. The world we inhabit, which once seemed so familiar, now appears as a place of far deeper and more mysterious architecture. It is as if we have been living our whole lives in a small sunlit room, only to discover that the room is a chapel within a vast and ancient cathedral. This cathedral is the earth itself, a structure built over 4.5 billion years. Its foundations are the signatures in the stone, the great rusted iron bands that speak of the world's first breath. Its tapestries are the fossil records, intricate weavings of the stories of life and of the great dyings. Its vaulted ceilings are the atmosphere and the great slow cycles of the climate, a breathing roof that shelters us all. And its acoustics are so perfect that they still carry the faint, resonant whispers of the beginning in the murmurations of a flock and the hidden language of the forest. Within this immense and silent cathedral, our own human story is but a single, flickering candle. Our entire history, every empire, every symphony, every discovery, every life, is like the dance of one small flame, lit for a brief moment in the vast and patient darkness. For a few thousand generations, we have held this light of consciousness, and with it, we have explored the ancient halls we inherited. We have found the ghost in our DNA, a strange and beautiful hymn written in a language we have yet to fully comprehend. We have learned to tame the fire, and its light has allowed us to paint our own images, our own dreams upon the ancient walls. Our journey together has been an attempt to read the intentions of the cathedral's architect, to understand the purpose of this magnificent design. But perhaps the most profound realization is that the architect may be gone, and that the final chapter of the story was intentionally left unwritten. The cathedral is finished, the inheritance has been passed down, and the candle has been lit. What happens next is up to us. We are not just visitors here. We are the inheritors of this sacred space, the children of the gardeners, the waking mind of a living world. The great open question is what we will do with this brief and brilliant moment of light that we have been given. Will we be a fire that consumes, that scorches the ancient tapestries and cracks the foundational stones, leaving behind only darkness? Or will we be a light that illuminates, that reveals the beauty of the cathedral for the first time, adding our own verse to the great silent song of the earth? The story of the gardeners may be just that, a story, a myth to help us comprehend a reality that is perhaps even stranger and more beautiful than we can imagine. But the cathedral is real. Our responsibility to it is real. And our fleeting, precious moment of consciousness is real. We are here now, awake in the ancient and silent nave, and the choice is ours. And so the light of our small candle continues to burn, its gentle flame holding back the immense and patient shadows of the cathedral, a quiet testament to our brief and wondrous moment of awareness. The great questions we have explored together, of gardeners and ghosts and ancient sleeping minds, need not be answered tonight, for their purpose is not to be solved, but to be held, to expand the quiet spaces of our own imagination. The weight of our responsibility as inheritors can be set down for now, left to the care of the coming day, because the night is a time for rest and for allowing the great, slow rhythms of the world to hold us once more. The story we have told is just one of many possibilities, a gentle myth whispered against the vast and profound silence of what is truly unknown, a dream of a world more full of purpose and memory than we might ever have dared to guess. Let the echoes of this journey fade softly now, like footsteps receding down the long stone aisle of the cathedral, leaving only a sense of quiet wonder. As you settle into your own peaceful darkness, allow this single thought to remain, that you are a part of a story immeasurably vast and beautiful, a precious, thinking, feeling piece of a living, dreaming world. The great cathedral of time is quiet now, and the small warm flame of your own awareness can now soften to a gentle sleeping glow.